Lesson 3-5. Today, what we're going to be looking at is the graphs of sine and cosine, but this time with more transformations. So here you're given the general forms of both sine and cosine with transformations. We're going to call these sinusoidal functions. Here's the word right here, sinusoidal. It's very weird. What sinusoidal means is we have a sine or cosine function that has certain transformations that have occurred.
This was been given yesterday. Doesn't
We're also going to look at this formula down here. It's called the cofunction formula. We'll see that later. But for now, let's start with this. On this slide here, I want you right here, this is like a cheat sheet that I will go over as we go through today. So I'm not going to spend any time here. It's a cheat sheet for you later. Here's what I'll make note of. The general forms of the sinusoidals are at the top of this, okay? So if you're wondering, like when you're looking at this, what's A, what's B, what's C, what's D? Well, you look up here to see where they're located, okay? So this is just a cheat sheet for you, but I'm going to go over it as we go through today, so I'm not going to spend time on this slide. All right, getting started. What we're going to look at today first is a picture of graphs, and we're going to find the amplitude, midline, period, and frequency. After we do that, we're going to write the equation of the sinusoid. So the first time, excuse me, not the first time, the first thing that we're going to do each time is determine, is this a sine or cosine function? Which function would most easily represent this graph? That's what I want to determine first. And so here's the question I want to ask you today, is when you look at the y-axis, does this wave, I'm going to call the y-axis the beginning, does this wave begin at its maximum or minimum value? Okay, so this first time, go ahead and label that this graph begins at its maximum value. Now, what does that mean? Well, if you think of a unit circle, sine is which variable again? Sine is on a unit circle. Sine is y and cos is x. Okay, good. When you translate to a unit circle, I want you to think of the x-axis representing cosine and the y-axis representing sine. On a unit circle, where do you begin on a unit circle? Up, down, left, or right? Right. We begin on the right. That's where 0 would be. Remember, pi would be here and 2 pi is there. Okay, we begin at this point here. Which variable is at its maximum? Is x at its maximum or is y at its maximum? X is at its maximum because we're furthest right. Y is at its midline. It's at the middle value. So you see how x is at its maximum? X is at its maximum right there. Do you see that? This function would be cosine. Since the graph is at its maximum, on the y-axis. Okay, so that's how I know this is a cosine function. How do I know it's a cosine function? Because on the y-axis, the graph is at its maximum. If it was sine, where would the graph be located on the y-axis? The midline, the middle. Okay, and that's the first thing we're going to determine. Now, secondly, I'm going to find these values. So the second thing we're going to find is the amplitude. Now, the amplitude, you might remember me saying, it's the top of the wave to the bottom of the wave divided by 2. So if you looked at the graph, the amplitude is actually going to be the top to the bottom divided by 2. How many units is it from positive 5 down to negative 1? That's 6 units. And when you divide 6 by 2, what do you get? 3. So the value itself is 3. If you want a formula, the formula you would use is that the A for amplitude is max minus min divided by 2. That's if you needed a formula, but here looking at the picture, you can just see it's 6 units from top to bottom, and 6 divided by 2 is 3. Everybody tracking? That will be our A value in this case. A will be 3. So I'm going to go ahead and put that. The second thing we're going to find, excuse me, that was the second thing. Let's do midline now. If I'm looking for the midline, that's the middle of this graph. Let's go 3 here, midline. This is always a line, hence midline. Tell me when my line that I'm about to add to the graph becomes in the middle. So I'm going to add this line here. Tell me when this line has become the middle of the wave. Is it there? No, that'd be the max line. There? No. There we go. That's the midline. Because it's a line that's got slope to it, you would say it's y equals What y value do we cross through?
2.
2. The slope is 0, by the way. Slope is 0, it's flat. So the equation is y equals 2. So on midline, be very careful. When you go to your delta math, you're going to have to put y equals. If you don't put y equals, that's going to count it wrong. Y equals 2. For the equation, when we write our equation later, this will be the value d. You would say d equals 2. That's going to be the equation that we write with. All right? Number 4, we're going to find the period. So the period means one full cycle. So when you look up here, I think it's easiest to go from max to the next max. And it's a horizontal distance. So I hear 2 as in 2 blocks, but look on the x. We go from 0 to, what does this second block represent?
Pi.
Pi. So pi is going to be our period. Pi is equal to the period. I forgot to come back and write amplitude on here. I'll give you an amplitude over here. Top to the midline is actually an amplitude. So that would be 3 for the amplitude. I'm just going to say AMP there. That's what amplitude looks like. The period is there. So our period is pi. Now, in the equation, this is the letter B. Period helps us find the letter B. Here's how you'd find your period. The letter B, I'm sorry, not the period. The period is pi. We know that. For the equation, we need to find the letter B. The formula is that the period, which is 2 pi divided by B will equal the period. So 2 pi over B equals the period of pi. And you solve this equation. Now, y'all could probably do this mental without even doing the algebra. 2 pi divided by what gives me pi? Very good. Y'all agree with that? 2 pi divided by 2 is pi? Would that make sense? So just go ahead and put over here that B is 2. You could solve it all the way if you wanted to. You'd multiply by b, then divide by pi, but I'm going to leave it like that for the sake of time. 2 pi divided by 2 is pi, so b will be 2 for our equation. Finally, the last thing we're going to find is the frequency. The frequency is how many cycles it completes in 2 pi. It is always the reciprocal of the period. The frequency, once again, is always the reciprocal of the period. If my period is pi, it means you flip it. So it becomes something divided by pi. If this does not have a denominator, what do you think you put for the numerator here? 1. This is the reciprocal of the period. You see how it's the reciprocal like that? By formula, it would be b over 2 pi, but we already have the period, so you just flip it. So now we can write our equation. There is no phase shift in this. We're not shifted left or right. That was one word that was over there. So the equation on the previous page said you're going to write an equation in this form where it's, we said cosine. So it would be a cos bx minus c plus d. That's how the equation should look. So we're going to plug in our numbers. Our equation will be y equals, what's our a value? 3. A is 3, the amplitude. 3 cosine, what's our b? 2. Now, this graph does not have a c at all. No, here, if you want to add this in, this has no phase shift. A phase shift is when it's shifted left to right. If there's no phase shift, what that means is c is equal to 0, and you don't include it at all. If you don't have to include it, you can just say 2x. You don't have to have that parentheses. It's just going to become cosine of 2x, and I'll use it like this. Since I don't have the bracket supposed to, so you can see that this is a parenthesis, this is a second parenthesis, just to keep, you can tell what goes with what. Since there's no c at all, I don't need this parenthesis, therefore I'm going to change the bracket and just say cosine 2x like that. And then what's our d value? 2. There's our equation right there. That's how it would look. Now, I don't want anybody to be confused. You're going to see me do this a couple times. I'm going to do it 3 times. So you might have some questions right now. Just hang on for a moment. Let's see it 2 more times, and you'll probably figure it out a bit. So there would be your equation. Okay, I want to reload. I want to look at part B. Let's look at the second one. First, it says use the graph to find the same values. So what did I actually do first last time? Let's determine if it's a sine or cosine. Go to your y-axis. The intersection of the y-axis is right here. Does that appear to be the maximum of the graph or the midline? That's a point in the midline. Okay, does that make this a sine function or a cosine function? Sine function. I want you right here. This is a sine function. Let me make sure my words are aligned. Why did I say cosine since the graph is at its max on the y-axis? Okay, we're going to say sine function since the graph is at its midline on the y-axis. So sine begins at its midline. If you think of the unit circle, the y value is at its middle value when you start, whereas cosine begins at its maximum on the y-axis. Okay, so this will be a sine function. Now let's go through the process to find the amplitude. I'm going to go ahead and put a midline on just so we can see it better. Tell me where my midline would be, and then we'll find the amplitude from there. Where should I stop for the midline? I guess I already had it written, didn't I? What y value is that? Y equals -3. Okay, to find an amplitude, you go from the midline to a maximum. It doesn't matter which maximum you choose, they should all be the same. How many units is it from here to there? 5 units. So 5 is the amplitude. So here we go. The amplitude is 5. For the equation, what letter is the amplitude represented by? A. So we're going to say A equals 5. If you plugged in that it's number 2 in for the max and you subtracted the minimum, -8, and divided by 2, you'd also get 5. That's the amplitude. Okay, now, we already did midline. It's on the board. What is our midline? If you say -3, delta math will count it wrong. Y equals -3. Now, in the equation, this will not go in the place of y. What will it go in the place of? D. Our D will be -3 on the equation. Line these up like that. Okay, now for the period. What represents the period by picture? A full cycle. So if I started here and I started going, is this one full cycle to this point? Well, no, that's half the cycle. That only includes the maximum. It does not include the minimum. So we need to go all the way to here. How many units apart is it from 0 to 4 pi? 4 pi. That is our period. 4 pi is the period. So 4 pi is equal to the period. Let me go ahead and write that down. So our period is 4 pi. Now, for the equation, the period comes from the letter B. The formula for period is 2 pi divided by B. So here's what I'm going to do. Instead of writing period here, I'm going to say 2 pi divided by B equals the period, which we know is 4 pi. Now this one, I don't know what value to put there to make this equal, so I'm going to actually do the algebra. What step would you do trying to get B by itself? Right now I'm dividing by B. What's the opposite of dividing by B? So you multiply both sides by B. And so 2 pi would equal 4 pi times B. Last step, how do you get B all by itself? Divide by 4 pi. And now we will know what our B is. We have B by itself. Pi's will cancel. What's 2 divided by 4? 2 divided by 4 is not 2, it's 1/2. Our B value will be 1/2. Last thing we have to find is the frequency. Now, frequency is the reciprocal of the period. Since I already know the period, I just take the reciprocal. What's the reciprocal of 4 pi? Nope. Reciprocal means flip. So 4 pi goes to the denominator. What do I put in the numerator? 1. There was nothing in the denominator here, so I just put a 1. That means it completes one cycle every 4 pi. It'll complete one cycle every 4 pi. That's what the frequency means. All right, with that, we can write our equation. On that one cheat sheet, the cheat sheet said that you could have a sinusoidal function in this form. Oh, one more time. Do I have a phase shift? Am I shifted to the left or the right? No. So no phase shift. And if there's no phase shift, what letter does that mean? Is it 0?
C.
C equals 0. So since there is no C, you could drop the brackets and just use 1 parenthesis. So my equation would be y equals, what's my A? 5 sine. I don't need this bracket and the parenthesis because C is 0, so I'm just going to change the bracket to a parenthesis since I only have 1. B comes first. 1/2 x. Close your parentheses. What's my D? -3. You got it. That's my equation right there. Questions over that? Yes, ma'am.
So is the period 4 pi or 1 pi?
Great question. The period is 4 pi. That's how long it takes to complete one cycle. The b value is what goes into the equation from which you can find the period if we were working backwards. Like if I gave you the equation, you would use the b to find the period, but the period itself is the 4 pi. That's a great question. The period itself is 4 pi. The frequency is the reciprocal of the period. It's not the reciprocal of b, it's the reciprocal of the period. So these two are related. And by the equation, you would use the b to find them, but that's ultimately the b is not the period itself. Okay? All right. I'm going to give us one more. I know there's extra practice. I'm not going to do D and E, but I will do C. I want to see kind of if you can guide me through it. First, if we were going to use write a sinusoidal function, what type of function would you say this is? Why do you say it's a sine function? Okay, if it's on its midline, if the function begins on its midline, it would be a sinusoidal function. That's correct. Is this the, no, that's the wrong one. Sorry. I'll go ahead and put the midline on there. Okay, it is a sine function. Okay, I'm going to find amplitude next. The amplitude. When you look at the graph, it's the top to the bottom divided by 2. How many units is it top to bottom? No, top to bottom. How many units is it?
2.
2. And we divide that by 2, you get 1. Okay, so you were saying the amplitude is 1. You're correct. Now I'll draw it. An amplitude, you could say it's from the midline to its maximum. So 1 is the amplitude. The second thing we're going to find is the midline. Excuse me, third thing. And this is y equals, what value are we cutting through?
0.
0. Y equals 0 is our midline. Make sure you put y equals. Hey, you count it wrong. All right, how about the period? If you have a picture, how will you find or determine the period? One full cycle. Okay, if we start here, is this one full cycle right there? No, that's not one full cycle. That's half the cycle. We haven't gotten to the minimum, so now this is the full cycle. How far is it from 0 to pi? Pi. So pi is our period. Pi is equal to the period. Okay, now the period is not the letter B, but you can use the period to find the letter B. What is the formula for period? So you'd say 2 pi divided by b. That means period. That right there, a substitution. Period is 2 pi over b, just to be clear. Period substitutes to become 2 pi over b. That's what the formula is for period. My period itself, though, in the problem is pi. This is another one we probably don't need to do the work. I bet you can guess. I forgot to write A here, and I forgot to write the letter D. What does B need to be? B is going to be 2. 2 pi divided by 2 would give us pi. So B itself is 2. All right, last thing we're going to find before we write our equation is the frequency. The frequency is what value? What is it the reciprocal of? The period. So if my period is pi, what's the frequency going to be? 1 divided by pi. You got it. We can write our equation. Oh, sorry. Phase shift. Is it shifted at all, or is it again perfectly at its midline? Perfectly. No phase shift. We will see phase shifts later. No phase shift. Right now, I didn't want to mess with it. What that tells us is that our C is 0. Okay, so on that cheat sheet at the start, the equation I gave you for sine would be A sine bracket B x minus C, close your parentheses, close your bracket, plus D. On this particular problem, do we have a C? So I don't need this parentheses. Since I don't need that parentheses, I'm going to change this bracket to become the parentheses. So my equation would be y equals, what are we going to put for A? 1. Do you actually need to write if 1 if it's multiplying? No, you can just write sine. What's our B? So it becomes 2x. And then what's our D? 0. Do I need to put a plus 0? No, that will be your equation right there. That's it. All right. There's extra practice. You can look on Google Classroom. I'm going to upload those later to get all the values if you want to do this. But for right now, for the sake of making sure we can cover everything in class, I'm not going to do these here. What I want you to do is go to the back of the packet and try number 1. And as soon as you finish number 1, then try number 4. Okay, now we're going to take a look at, instead of me giving you pictures, I'm going to give you the equation, and we're going to use the equation to find the same values. This time we'll have phase shift in there. So I'm going to kind of go in the same order. We don't have to find the function. They'll tell if it's a sine or cosine. The one thing I need to have here is a parenthesis around 5x. Go ahead and add that in. I should have had that. That's my fault. So I should have had that. But we will first find amplitude. And so by formula, amplitude is represented by which letter? A. What is A in our problem? Perfect. A is 3. Therefore, the amplitude is 3. By the way, amplitude is always a positive value. So even if this said -3, you would make it be a positive 3 for amplitude. Because by formula, it's maximum minus minimum divided by 2. Okay, secondly, we're going to find the midline. Which letter finds the midline? Do you remember? Not B. D. That's the number adding or subtracting on the outside. What is our D in this problem?
7.
Good. So by formula, the midline would be? Very good saying y equals. Because if you just put 7, once again, it's wrong. Okay, how about the period? How do you find period if you don't have a picture?
Use the formula 2 pi over.
You use the formula. The formula for period is 2 pi over b. So what is our b in this problem? 5. It's 2 pi over 5. That doesn't reduce, does it? So it's just 2 pi over 5. So the formula, I'll just go ahead and put that here so you know it's 2 pi over b. So that's why it's 2 pi over 5. Okay, that's our period. And in my opinion, the easiest of all, the frequency. How do you find the frequency?
Reciprocal.
It's always the reciprocal of the period. Not 5 pi over 2, but 5 divided by 2 pi. That means it completes 5 cycles in 2 pi units. Finally, this one says phase shift. Color if I not use black. Phase shift. Phase shift is represented by the letter C. What is our C in this problem? 0. C is not there, so C is 0. Therefore, there is no phase shift. I'll do NA since C equals 0. It's not applicable. Make sense? Okay, then in that case, let's reload and do this again. First thing we're going to find is our amplitude. You know what? I'm going to leave a space. Leave a space here because I want to change this equation in a moment. We're going to have to change it. So leave a space. We're going to write one line in between. Amplitude.
One. Negative.
I heard 1 and -1. By rule, amplitude is always positive. So even though our A value is -1, even though the A is -1, amplitude is going to be +1. Good. What about the midline? Y equals 4. Y'all are catching on great and quick. This comes from which letter in the equation?
D.
D. Good. 3, the period. This one, I'm not going to write the value right away. What's the formula for period? 2 pi over b. In this particular case, what is our b?
1/3.
Our b is 1/3. So what this means is what we're truthfully doing here is we're taking 2 pi and then we're dividing it by the fraction 1/3. Do you know what to do when you're taking a number and dividing by a fraction? Do you remember? I'll call it an 8th grade rule. I don't know if it's actually 8th grade, but it was a long time ago you learned this. You multiply by, not multiply by 1/3. You multiply by its reciprocal. So what that means is you take 2 pi and you multiply by 3/1. And since multiplication and division are opposites, if you're dividing by 1/3, that's the same thing as multiplying by its reciprocal. What is 2 times 3/1? That would be 6 pi over 1. So just 6 pi. That is the period. Right up here, the b is the value that's multiplying or dividing x. Since x was being divided by 3, that's like 1/3. Make sense? Okay, the easiest of all is the frequency. 1 over 6 pi. Perfect. You have one cycle every 6 pi's. That's what frequency means. Now, finally, the one that's a little tricky here is the phase shift, because at first glance, most students would say it shifted how many units? Well, x's are liars. So you would think +2 at first, but that's not right. Do you remember how in the formula, let me go back to the cheat sheet. If I go back to the cheat sheet right here, do you see how b is separated from the x minus c? You see how that's factored out for both cosine and sine? We need to have it factored out, and we haven't done that yet. So remember how I told you leave a space? Truthfully, we would need to, if you wanted to use the equation, you would need to factor that out. So it would look like this. You would have -1 times the sine. This time use a bracket with a 1/3, followed by a parentheses. So what I'm doing is I'm dividing out the 1/3. I'm dividing out 1/3. So 2 needs to be divided. This c value, this is c. C's value needs to be divided by 1/3. So 2 needs to be divided by 1/3, because that's what I'm doing. I take 2 and I'm dividing out 1/3. So actually I should do a c with an asterisk, because that's c is not actually -2. We're going to change it here. The true c is 2 divided by this 1/3. Now what happens? We just said when you divide by a fraction, you multiply the reciprocal. So it's 2 times 3/1. What's 2 times 3/1? 6. So this is, if it's a -6, it is a phase shift of right 6 units. I think on delta math you just say positive 6. I don't think it has a space for right, but right would be a positive 6. Oh, let me go ahead and finish this equation. So it'd be x minus 6, close your bracket, plus 4. That's what should go there. That's what the 1/3 factored out. That's how the equation should look right there. Once again, I have some extras that you could look at, but for sake of time, I'm not going to do the extras. I'm just going to leave it there. And we're going to jump on to the back of the packet and try number 3. So go next DOL, we're going to try question number 3. Example 3. Now, as you come here, this is actually our second learning objective of the day. I'm not going to go back to learning objective, but it's going to compare the values of cosine to sine of x plus pi over 2. We're going to look at what the comparison between these values. We're going to do so by completing this table. Now, I'll do part A, B, and C as we go along. Let's first start with finding the cosine of 0. So, using our hand trick, the cosine of 0. Looking at your left hand, which finger represents 0? Pinky. Take your pinky, bend it. Flip your hand over. Is cosine x or cosine y? Cosine is your x's. How many x's do you have at that spot? You have 4 x's. So this would be the square root of 4 divided by 2. Remember, cosine and sine are always divided by 2. And it's positive. Let me draw a quick unit circle because where is 0 located? Which direction? To the right. This is 0. This is pi. This is 2 pi. We're at a positive number because we are to the right. Cosine's x. Or to the right, x is positive. Okay, so square root of 4 over 2. Let's reduce that. What is the square root of 4? 2. And what is 2 divided by 2? So put that is 0 to 1. Let's go to the graph. 0 to 1, put a dot. Everybody with me? Now, let's find the sine of x plus pi over 2. So on this problem, x is 0. So what is 0 plus pi over 2? 0 plus pi over 2 is pi over 2. So on the hand trick, which finger is pi over 2? Thumb. Bend your thumb, flip your hand over. How many y's do you have there? It's the square root of 4 over 2. Now this should make sense because on the unit circle, pi over 2 is located straight up. And when it's straight up, y is now at its maximum. Square root of 4 is its maximum over 2. I can reduce that. What is the square root of 4? 2. And 2 divided by 2 is 1. Sine and cosine have the same first point. Excuse me. Cosine and sine of x plus pi over 2 have the same first point. Okay, let's find the next key value at pi over 2. So we're plugging in pi over 2 this time. So what is the cosine of pi over 2? Okay, question. Which finger do I use for pi over 2? Bend your thumb, flip your hand. How many x fingers do you have at pi over 2? Not 4. How many x fingers? 0. So it's the square root of 0 over 2. What is the square root of 0? 0. And 0 divided by 2 is 0. Now this should make sense because on the unit circle, cosine x should be at its midline, the middle value, when we're at pi over 2. So that makes sense. So at pi over 2, go to pi over 2 and put a point at 0. Now let's find the sine. When I plug in pi over 2, it becomes sine of pi over 2 plus pi over 2. I'll say it this way. Pi over 2 is the same thing as half a pi. It is sine of half a pi plus half a pi. It becomes 1 whole pi. What is the sine value of 1 whole pi? I don't know. Let's use our hand trick. Which finger do I use for 1 whole pi? Pinky. Bend your pinky. Flip your hand. How many y's do you have there? 0. So it's the square root of 0 divided by 2. What is the square root of 0? 0. Divide that by 2. 0. What do you notice happens? So our first 2 points, they're exactly the same. And this should make sense because at pi, sine is at its midline. Y is at its midline. It's not positive, it's not negative, it's at its midline, it's 0. Okay, how about the next one? Pi. Cosine of pi. Which finger do we use for pi? Pinky. Bend your hand. Flip it over. How many x fingers do you have? 4. Okay, now we're going to ask, is it positive or negative? Look at our unit circle. Is x positive or negative? When you look, it's negative. So this value should be negative 1, 0. I should have wrote those on as we went. Okay, so cosine is negative 1. So we have negative square root 4 divided by 2, which is going to reduce to be negative 1. At pi, we should have a point at negative 1. Go ahead and add that to your graph. Whoops, I was wrong color. Let me fix that to orange. Sorry. There we go. Okay. Now I'm up to date. Now we're doing sine of pi plus pi over 2. Okay, I want you to think of this. Using the unit circle. Pi over 2 is a quarter of the circle. Pi is half the circle. We're taking sine of pi plus pi over 2. That means sine of half the circle plus a quarter. Where are we at now?
3 pi over 2.
3 pi over 2. We're looking at sine of 3 pi over 2. Y'all know what the value we're going to get at sine of 3 pi over 2? What's the y value going to be at 3 pi over 2? Negative 1. It's going to be negative 1. We're going to have a negative 1 for sine to the y. So this will equal negative 1. That means it must have been, if you use your hand trick, negative square root 4 over 2. I'll check it out. Sine 3 pi over 2. That's your thumb. Keep in your thumb. Flip your hand. You'll notice you do have 4 y fingers. So it's negative square root 4 because we're down, divided by 2. Go ahead and add that. All right, we got 2 more here. 3 pi over 2. 3 pi over 2. Which thumb is, or which finger is 3 pi over 2? Gave it away. Thumb. In your thumb, flip your hand. How many x fingers do you have at 3 pi over 2? 0. So it's the square root of 0 divided by 2 equals 0. At 3 pi over 2, we should be at 0. Now you can fully tell what this wave is going to look like. Let's go to sine. Any predictions on what we're going to get here? We're going to get 0. Let's try it. Sine of 3 pi over 2 plus pi over 2. What is 3 pi over 2 plus pi over 2? Remember, when you add and subtract with fractions, you don't change the denominator. 3 pi over 2 plus 1 pi over 2 becomes 4 pi over 2 or 2 pi. So which finger is 2 pi?
The thumb.
Pinky. And your pinky, flip your hand. How many y fingers do you have there? 0. Square root of 0 over 2, which is simply 0. You can check over here at 2 pi, the sine value is 0. So put that point there as well.
Okay, I found this on the web for check sign.
Oh, Siri. Okay. Finally, last point. Cosine of 2 pi over 2. We can just use your unit circle. Units. What is the cosine of 2 pi? Use the unit circle. Cosine of 2 pi is 1. And now, what's the sine of 2 pi plus pi over 2? Well, that's like taking a full circle and then going another pi over 2. What's the sine value there? 1. No, not 0. Sine is what? 1. So that's a 1. We plot those points. At 2 pi, cosine is 1. Wrong color. The cosine is 1. And when you do sine of 2 pi plus pi over 2, we also get 1. Connect that with the wave. It is a wave, so connect it with the wave. There's your graph. What can you tell me about both those functions? They're equal. Okay, this is called a cofunction relationship. These are called cofunctions. That cosine is the same thing as sine plus pi over 2. Called cofunctions. Cofunction is any value, any function that when you add or subtract a pi over 2, if the functions become equal to one another, they're called a cofunction. So sine and cosine are cofunctions. Here's how you can remember that. Say sine. Say cosine. What's the difference between the two words you just said? The word co. Sine function is a cofunction with the cosine function. Cosine is a cofunction with the sine function. Let's see if you're tracking with me. Tangent is a cofunction with
Cotangent.
cotangent, not cosine. Tangent is a cofunction with cotangent. Cotangent is a cofunction with tangent. You'll see that those are going to be pi over 2 apart. But if you add or subtract the pi over 2, you'll get the same equation. All right, one more. Secant. Remember that word earlier this year? We have a secant function. What's its cofunction going to be called? Cosecant. If you add or subtract a pi over 2, cosecant will become secant, or secant will become cosecant. They're pi over 2 apart. That's what cofunction means. Okay, what does cofunction mean? Pi over 2 apart. Cosine and sine are pi over 2 apart. Remember how the c value shifts it left and right? If you shift it pi over 2, you end up with the same graph. Okay? Go ahead. Let's look at this next one here. Now, I have another one here. Is it okay if I change this to extra practice? Why do I say that? Because what does this say? Sine. What is this one? Cosine. What do you see happen to be inside here? What should happen if you're dealing with sine and cosine with a pi over 2 shift? These are going to equal one another. These are cofunctions. Since they're cofunctions, we'll get the same graph. So I'm not going to actually work this one. And I just remembered I skipped a line, didn't I? Come back here. I skipped a line. Part D. Is cosine even or odd? What even means is this reflects on the y-axis. Let me just write this in. What even means is it reflects on the y-axis. Actually, I shouldn't say on. I should say across. Reflects across the y-axis. That's what it means to be even. Does anybody remember from first semester what it means to be odd? If it's odd, it doesn't reflect across the y-axis, it reflects across the, good guess, the origin. Okay, look at our picture here. Does this graph, I did a little arrow. I guess I could have kept on trying to draw the points. If we kept on with this, this would actually go through here. If I kept on with this wave, how is that reflecting? Is it reflecting across the y-axis, or is it reflecting across the origin? The y-axis. You see how this is up and to the right, this is up and to the left from the origin? Here's the origin. Come on, folks. Take eyes on here. Stop zoning out. Here's the origin right there. Is this part, whatever this point is, does it reflect diagonally across the origin? Does this point right there reflect diagonally across the origin? Does this point reflect straight across the y-axis? Yeah, y-axis. Therefore, it's going straight across the y-axis. This is a even function. Okay, I don't want to take all the time to work through this, but here's what I say. The sine function, we will do a unit circle real quickly, and we'll do the sine, and then we'll just assume what I said is true. So unit circle with me real quickly. Now, when I say draw a unit circle, I want you to draw a circle with the y-axis cutting through the circle and an x-axis cutting through the circle. Go ahead and do that, please, on this next one. We will write in 5 values. On the right side, put an x there. At the top, put a y. Put a y there. And then on the inside, I want you to put 3 radian values. What do I want you to put here? 0, pi, and 2 pi. By way of reminder, radians mean count of radiuses around the outside of the circle. I want you to put those. For sine, sine is a measurement of the x's or the y's? Y. So my first point is 0, no, not 0, 1 comma 0. What's my first y value then? 0. Go to 0, 0, place a dot. My second value that we're finding is pi over 2. Here's pi over 2. What's the coordinate of pi over 2? 0, comma 1. Therefore, what's the sign at pi over 2? 1. Okay, at pi. What's the coordinate at pi going to be? -1 comma 0. So what's sine at pi?
Zero.
Okay. Oh, I forgot to put this one. At pi over 2, we're 1. At pi, we're at 0. How about 3 pi over 2? What's our coordinate going to be? Our coordinate? 0, -1. Y'all are catching on really fast. And what about at 2 pi? 0. That's it. Okay, connect those dots. I didn't put this one and this one. Connect those dots. Okay, the reason I wanted us to draw this is so you can make your judgment. Is sine itself even or is it odd? How is this reflecting? I'll give you an idea. Here's the origin. Here's a point. How is this reflecting? Is it going across the y-axis or is it going across the origin? How does sine reflect? Across the origin. Therefore, it is odd. The O's go together. It reflects across the origin. I'll put that one more time. Reflects across the origin. Reflects across the origin. That's what it means to be odd. The cosine values, if you plug that in, you'd get the same exact values as sine. The cosine of pi over 2 minus x, if you plugged in these x values, you'd get the same exact values. So with that, I want you to go try one. We're going to try, try one, try two. We're going to try number 5 and then number 6. Try number 5 and then number 6. Example 4 says a mass on a spring oscillates back and forth and completes one cycle in 0.25 seconds. Okay, they say this one cycle. What does it mean mathematically to be one cycle? One period. A period is equal to 0.25 seconds. Are you okay with that? Its maximum displacement is 6. What does displacement mean? It's amplitude. Very good. The maximum displacement, that would be the amplitude. That's the most it moves. And displacement can be positive and it can be negative. So this is telling you your amplitude is 6. It says write an equation that models the motion of the spring if it's released from its maximum height. Okay, if it's released, that means it starts at maximum. Which function is it if it starts at its maximum? Which the sine or cosine start at its maximum? Cosine. This is a cosine function. So what they're saying is it's released at its maximum. This is 6 centimeters. They told us that. Displacement involves positives and negatives. So if that's 6 centimeters, what would this value down here be? I don't like that they use the letter D. That would be -6. That's displacement for you right there. The only value we need to find that we haven't yet is the period. If the period is 0.25, what's the formula for period? And then maximum minus minimum divided by 2, that's the amplitude. We know the amplitude. The period, what is the formula for period? 2 pi over b. So if my period is 0.25, what that means is 2 pi over b is equal to 0.25. To help you solve that, it might be easier if you went to, well, we can go to a fraction. What is this as a fraction? Do y'all know? 1/4. Want to rewrite that as 1/4. Okay, how can you solve for b? Because that's what we're going to need for our equation. Multiply by b. Technically, if I wrote it this way, I would need to multiply the middle by b. Okay, this cancels. And so 2 pi is equal to 0.25b, which is the same thing as 1/4 b. How do you get b isolated now? I would look at this one. How do you get b isolated? What's the opposite of multiplying by 1/4? Okay, well, it's a fraction. Fraction means multiply by 1, dividing by 4. What's the opposite of that? Multiply by the reciprocal. What's the reciprocal? 4 over 1, which is multiplying by 4, yes, but I just want to make sure everybody sees that. You multiply by 4 over 1. So if you multiply everything by 4 over 1, again, you don't have to keep track of the middle one, but I'm just doing it here. What you're left with, again, these would cancel. What's 4 over 1 times 2 pi? 8 pi, good. B is 8 pi. So if we wanted to write our equation, the equation from the start of class was y equals a cosine b x minus c plus d. That's our equation. Let's plug in our numbers. Oh, this midline here. Here's the midline. The midline is 0. That's the midline. If you had a line going through like this, that would be the midline right there. That's the d value. So let's plug in all of our equation. Y equals, what's our a? 6 cos. Do we have a c? No shift left to right. Therefore, I'm not going to do the parentheses and the bracket, so I'm just going to do one parentheses. What's our b value? I forgot. 8 pi. So b is 8 pi times x, and d is 0. There's our answer to part A. There's your answer to part A. Now part B, what does it ask? Find the frequency of the behavior. How do you find the frequency? Reciprocal of the period. Okay, if the period is 0.25, that's the same thing as what fraction? And so what's the frequency? 4 over 1. Frequency is 4 over 1, which is just 4. And this one, what that means is 4 cycles per 1 second. 4 over 1, that's what it means. The frequency is 4, and I'm putting in the units there. It's 4 cycles per 1 second. 4 times it oscillates every 1 second. All right, with that, I think this is number 4. I added number 4 already, correct? Which ones have we not done? Just 2? Let's do number 2. Okay, we're going to take a look now at example 5. So here it says, consider the first period of each of the graphs given below. So on this first one, find the 5 key points. What did it mean to be a key point? Do you remember? We're going to identify zeros, maximums, and the minimums. Okay, so on this one, I see 1, 2, 3, 4, 5, 6, 7. Looks like there's actually 7. So if I labeled out these coordinates, this would be what coordinate? 0, 0. Okay, what's this coordinate? Pi over 6, comma 3. Okay, here. Pi over 3, comma 0. The x goes first. Next one. This one. 2 pi over 3, comma 0 here. 5 pi over 6, comma 3. And finally, oops, pi, comma 0. Those are the key points that are shown here. Identify where the function is concave up and concave down. Tell me about this first section. What is that? Concave down. This is concave down in here. What about this part? Okay, I'm going to say C up. What about here? What would this next section be? Okay, so here's how you would write that. What you would do is you'd write the first interval for concavity. This is concave down, or concave down first. Where do we start from?
0.
0 to pi over 3. When you do intervals, you do x's, by the way. It'd be from 0 to pi over 3. Where are we concave up? From pi over 3 to 2 pi over 3. And you would start seeing these repeat starting at 2 pi over 3, we'd repeat in the same distance apart. So you can actually come up with repetitive values with formulas, but for now, I'm just going to leave it like that. Where's the function increasing, decreasing? Well, what's the graph doing at first? Increase, what about here? Decrease, what about here? Increase, y'all are getting it. Last thing, where are the points of inflections? The zeros. Very good, zeros. Okay, I have a part B here. Identify for me what's happening at the start of this first period. Are we concave up or concave down in here? Concave down. Are we increasing, decreasing? Decreasing. Yeah. What about in here? Concave up, concave down? Concave up. What's happening on the graph from here to here? Decreasing. What about here to here? Increasing. Good. Points of inflection would be, where do you see points of inflection? Pi, comma 0 and 3 pi. Okay, we're going to skip over that. And we'll skip over C. You can do that extra practice. Go ahead. Now let's take a look at number 2. Let's knock out number 2 now. All right, now we're going to look at example 6 here. Now, example 6 is going to be set up like a typical AP free response question. It says a buoy oscillates as waves go past. Again, oscillate just means it goes up and down in a repetitive pattern. The buoy moves a total of 4.5 feet from its low point to its high point, and then returns to a low point every 12 seconds. So from its low to high, it's 4.5 feet. Now, low to high would be twice the amplitude. Okay, so I want you to think about that. Low to high would be 2 amplitudes. All right, whereas returning to a low, this would be 1 period. So low point to high point, that is 2 amplitudes. Because remember, it's top to bottom divided by 2. So that's 2 amplitudes. And low point every 12 seconds, that's going to be 1 period. So it says, if the buoy is at the lowest point at t equals 0, find all the coordinates of the 5 key points. So I'm going to look at this graph, and so you can see in this picture, I can't quite get another low point, so I'm going to extend this back here like this, and this will help me out. If this is the low point, we'll call this low point. That's when t equals 0. I'm going to extend this off this way as well. We're going to say that point is t equals 0 right here. We know the buoy moves a total of 4.5 feet. So what we're going to do is that's 2 amplitudes. We're going to take 4.5 and divide that by 2. 4.5 and divide that by 2, and you get 2.25. Here's what that means. This y value, if the x value is 0, is going to be negative 2.25 feet, assuming that the midline is at a height of 0. I'm going to call this y equals 0, the midline. So that would be my first point. Now, the next low point will happen 12 seconds later. So the next low point would be 12 comma negative 2.25 again. So that's where that would be. Now, the highest point will be 2.2 up, and it'll be half the way between 0 and 12. So half the way between 0 and 12 is 6 seconds, and this would be up 2.25. So now we have these 2 points left, because remember there's 5 key points. So this value and this value are the only ones left. I'm going to switch colors. This has a height of 0, and it's halfway between 0 and 6 seconds. Obviously, that's 3 seconds, so this would be 3, comma 0, and this point right here. That's half the time between 6 and 12 seconds, which means it's 9 seconds. So it would be 9, comma 0. Those are my key points. So on this first wave, or this first cycle, you have 2 zeros. You have the two zeros, which occur at 3, 0 and 9, 0. You have one maximum, which would occur at 6 seconds, 2.25 feet up. And then you have two minimums, and those occur at 0, negative 2.25 and 12, negative 2.25. Those would be our 5 key points right there. Now it says write a sinusoidal function that would represent this situation. Okay, so remember our amplitude here, that is the letter A. Now the period we have is 12 seconds. If the period is equal to 12 seconds, what you do is you substitute 2 pi over b here. So 2 pi over b is equal to 12. And if you solve for b, what you would need to do is multiply by b on both sides. So 2 pi equals 12b, 12 times b, and then we would divide by 12 to get b isolated. And just like that, we can determine that b is equal to 2 goes into 12 6 times, or said another way, 2 over 12 is 1/6. This is pi divided by 6. That's our b. Since I'm starting at the minimum, I'm going to call this a cosine function. And I want to make a be a negative number because I'm starting at the min. So sinusoidal function, since I begin at 0, or I begin at minimum, since the graph begins at the minimum, I'm going to make it a negative cosine graph. I'm going to make it a negative cosine equation. Okay, that's a little bit too big of a minimum. That's a negative cosine function. Let's see what else. We found our b value. We know our a value. We're going to say it's not shifted to the left or right. I'm going to say no phase shift. Like we're going to say that is the y-axis. We get to pick where the y-axis is. It says it begins at 0. So we're going to say, since it begins at time, we're going to say no phase shift, which means that means c is equal is 0. And then we said the midline. We just picked 0, like let's just say sea level is 0. And we'll say that midline is going to be y equals 0. Therefore, our d value is going to be 0. Oops, d equals 0. What does that mean for my function then? My function would look like this. Y equals negative. Here's my a, 2.25. Cosine, because we began at the minimum. Since there is no c value, I could just do a bracket, but I don't need to do a bracket. I'm going to use just a parentheses. We're going to say it's b times x. B is pi over 6. So pi over 6 x. There's no c, there's no d. That's my equation right there. Okay, so you could actually say that a, if you wanted to, is negative 2.25 because of the negative cosine function. And again, I'm going to copy this down from over there, that b was I divided by 6. That way we have all the values right there. Okay, that's part A, part B, part C. What is true about the sinusoidal function on the interval 0 to t equals 0 seconds to t equals 3 seconds? So from 0 to 3 seconds, what is true about this? Well, it looks like we're on a concave up section. So if I took a picture of this here, I'm going to add this in. I'll just take this point of the graph. If I added this in here, oh my goodness. So I'm looking from 0 to 3. Goodness, still can't get it in there. Okay, we're looking in this interval from 0 to 3 seconds. There we go. From 0 to 3 seconds. The concavity, we are concave up. We are concave up. And if you're concave up, that implies by unbreakable chain that the rate of change is increasing. That's unbreakable chain from unit 1. So if you're concave up, your rate of change is increasing. The function itself is increasing. The function is increasing. And this is all in the interval, on the interval 0 to 3. On the interval 0 to 3. So is that everything? Oh, positive or negative? Is the graph positive or negative? Well, you're looking at the y values from 0 to 3 seconds. The function is negative. Function is increasing and the function is negative. We're dealing with the negative values. We're below the line y equals 0. Okay, now next portion, it says what is true about the sinusoidal function on the interval 3 seconds to 9 seconds. So from 0 to 9, let's see. 3 to 9, I'm sorry. From 3 to 9, what's happening? Well, here's 3. There's 3 seconds. And if I look between 3 and 9, the function is, it looks like concave down. So we are concave down here. Concave down. That's true in between there. The function is increasing and then decreasing. Concave down, by the way, that means the rate of change is decreasing. Rate of change is decreasing. Unbreakable chain. Okay, the function itself increases and function increases first on 3 to 6. Oops. 3 to 6. Then it decreases and decreases. 6 to 9. And let's see what else. Is it positive or negative? And it's positive. The function is positive. Now all this again is on the interval 3 to 9. Okay, finally, part E. I'll leave this one as extra practice for you to figure out between 9 to 12. Once you get that, I'll have it posted on Google. You can check. But don't forget to log in, submit all your answers online. All right, that's a wrap.